Good morning. Hello, hello, hello. Welcome to In Case You Missed Psychology for Thursday, November. Is it the 18th? God, I can't remember what day it is. It's the 19th. Oh my God, I almost made it a day worse than it is. So we made it to Thursday. We've only got one full day left in the week. If you're watching this, that means that you didn't make the class today for whatever reason. That's okay. We're going to run through just about everything that we covered in class. Obviously, you're missing out on trivia and some of the question and answer stuff that we're going to do today. And if we do get to the group work, you're going to miss that. But I hope you're well. I hope those around you are well. Hope you're doing okay. If you're not, man, reach out. We can talk. If you need a pep talk, if you're just struggling a little bit, I'm man, we're all struggling. I'm more than happy to chat with you. You can tell me your stuff. I'll tell you my stuff, and we'll try to have a little bit of a good time together. But anyway, like I said, if you're watching this, these are the things that we covered today in class. If you have any problems with any of the stuff, if anything's unclear, if anything's I don't know. Maybe this is a review for most of you guys, but if you're a little rusty and you need help, please let me know. Reach out. Here to help. All right. So the quick reminders for the day. Don't forget that your crash course, chapter 2, is due by midnight tonight. I was looking it over. It looks like a small number of you guys have got things turned in, but most people don't. So keep cracking on that. Get that done for me, so I get those graded in for you. Things have been going pretty well homework-wise for most of you guys. You've been really doing a good job. Writing has really been a strong point for a lot of you guys so far. So keep up the good work. And the reminder, make sure you're getting things in on time. It does make my life easier. It makes your life easier. It makes things a heck of a lot less confusing for me. I've got to go back and backtrack everything that doesn't get handed in and figure out if it's too late to get in and all that kind of stuff. So be responsible, get your stuff in. I try to make sure I give you an ample amount of time to get things done. And then when you do get things back, make sure you're reading and using the feedback that I give you. I'll give you an example. I am big into people restating the question rather than starting their answers with it and they. And if you look at my American history classes I have with the freshmen, some of them read the feedback. And so, first of all, they go back into their assignment and they correct those things that maybe need a little bit of work. They resubmit things, they get a better grade. But also, the next assignment that they do, if they've read the feedback, they know what kind of things to avoid. Some people keep falling into the same trap over and over again because they don't read the feedback. I'll tell you, I'm spending a decent amount of time on every one of you guys on every assignment because I want to make sure that I'm giving you ways that you can improve, or at least commenting on things that you're doing really, really well. I appreciate good feedback in my job, and so I hope that you guys appreciate good feedback as students, or we're just trying to help you get better. Okay. All right. Some things that we quickly reviewed. And if you've been in class, you'll know these topics. We talked a little bit about what ethics are, moral, right and wrong guidelines in psychology and science. We talked about the 4 rules that we talked about. They have the right to decline participation, quit whenever they want to, open and honest, confidentiality, and you have to assess the danger and the risk and try to remove any danger and risk. And then you're responsible for the people that are with you. We talked a little bit about operational definitions. Remember, that's the setup, what are we going to measure our variables in? Who are our subjects going to be? What are we going to consider success or failure with our hypothesis? It's the operational definition is basically just where we're laying out the what's what of an experiment, a survey, an interview, a case study, so on and so forth. And then last but not least, review the idea of they basically repeat, the ability to reliably repeat a study. If I do a study here in Marshall, Wisconsin, and I say I've made a great scientific breakthrough, somebody in Sydney, Australia should be able to do the same study and come up with similar types of results. Last thing, the placebo. Remember, a placebo is something that has no medical or therapeutic value except through the power of suggestion. They're often used in studies to try to see if is the actual experiment more effective than just the idea that the experiment may work. So those are kind of things we talked about. Today, what we're going to do is we're going to look at the parts of an experiment. And like I said, I know you're not here, but if we had enough time, we did some group work. And that group work obviously is focusing on the idea of being able to pick out parts of an experiment. Any other time you have planned for psychology today, use that to finish that crash course assignment. Like I said, it's due by midnight. So here we go. This is a pretty meaty slide, so I apologize in advance. There's a lot of stuff on it. you're just going to have to do your best. I'm going to magnify slightly so you can more easily see it. Whoops, and then it jumped me ahead. Let's go. It's going to let me go back. No, of course not. All right, we're going to go back down. Now it's just fighting me, period. All right, let's see. There we go. All right, you should be able to see that okay. Sorry about that. Technical difficulties, old guy operating a computer. All right, so what we're looking at today is experimental design. So we're looking at the basic parts of an experiment. We're going to break them down, what's necessary, what's needed, but we're also going to talk about what they are, and we're going to talk about how to be able to pick them out when you're looking at an experiment. So obviously, we're going to start off with the idea of a hypothesis. We talked about this in chapter 1. We got the definition, educated guess, and that's great and everything. It really does work at a minor level, but basically, what a hypothesis is it's the proposed explanation that becomes kind of like the basis of your study. You base your hypothesis on like limited evidence or someone else's work, and you use that as a starting point to investigate things further. And so there's a lot of hypotheses. People have hypotheses about literally everything. You can make a hypothesis about something that's going to happen in a chemistry lab. If I put the X thing in Y solution, Z thing is going to happen. You can make a hypothesis with a math problem. You look at the math problem, you're like, I think this number is going to come out between here and here. We can use hypotheses to try to explain people's behavior. If I tell my parents I did X thing, this is how I think they're going to react. You're basing that on limited evidence. I'm going to give you some sample hypotheses. I've kind of written some things down on a card to work with as we go through class today. Here are some sample hypotheses we're going to work through as we go through this slide. So first one is taking 1 aspirin per day reduces a person's risk of heart attacks. So that's something we could do an anatomy and scientific study on. Number 2, drinking sugary drinks daily leads to obesity. Okay, it's pretty easy. 3, eating red Skittles results in kindergartners displaying higher IQs. Okay, probably doubtful, but I mean, who knows? And then last but not least, most complicated one, because I want to have a complicated one to talk about. People are more likely to help in an emergency situation on a Monday than any other day of the week. Okay. All right. So those are all sample hypotheses, ideas that can be tested. We may have some evidence that shows us this is something worth looking at, but also we're not 100% sure that they're right. So we need to go through the process of doing some kind of data collection to figure out whether or not our idea is sound. Okay. The second thing in an experiment is you have to pick subjects. And I didn't want to overlook this. I know this is pretty obvious, but I didn't want to overlook this one. Obviously, subjects are the people, animals, or whoever the study is performed. And so obviously, if you're doing a study, you have to look for a group of people. You obviously probably aren't going to be able to experiment on everyone in a population. So you know that you're going to have to pick a sample. And we'll talk a little bit about samples actually next week. But you're going to pick a sampling of people to do your experiment on, or your survey, or you're having a sample of for your interview, or whatever type of study you're doing that we talk about. Now, the reason I wanted to talk about this is one of the things that gets overlooked is you have to find appropriate subjects for your survey. We don't want to grab a kindergartner for a driving test. We don't want to take someone who has a heart problem and put them on a treadmill unless our experiment has to do with cardiac patients on treadmills. We don't want to take someone who has really, really bad asthma and hasn't use their inhaler in a physical fitness study. So if we look at our hypothesis I just did, taking 1 aspirin per day reduces a person's risk of heart attack. We're probably not going to want to start doing this on like little kids, because how long are we going to wait for a study to be done? And so we might pick a population of people that are a little bit older. We might pick a population of people that have some history of like small, like maybe high blood pressure. Okay. 2, drinking sugary drinks daily leads to obesity. On this one, we really could. We could do just about anything. We could give lab rats Coke if we wanted to, and see if they get more obese. We could do this with little kids. It would seem kind of mean. We could do volunteer adults. We could pick people from all the different age ranges and see what happens. So really, just about anybody would be appropriate there. Eating red Skittles results in kindergartners displaying higher IQs. Obviously, I think that one's pretty self-explanatory. We need some kindergartners, okay? And then last but not least, people are more likely to help in an emergency situation on a Monday than any other day of the week. We're going to need people who are, first of all, capable of helping in the emergency situation. If it's something like changing a tire, we don't want a group of people that don't know how to change a tire. We don't want little children. We don't need 85-year-old senior citizens. We want people who are going to be capable of helping in the emergency situation that we have set up. Okay? All right. So we've covered step 1 and step 2. All right. So we have a hypothesis. Now we've picked our subjects. Now, the next thing that we're going to do is in our operational definition is we're going to have to define our variables. Now, the first variable I'm going to talk about isn't necessarily one you define, but it's one that is very important and you can't always plan for. And there's a lot of different words for this. I've seen people call them hidden variables, unexpected variables. I'm going to call them confounding variables because that's what they're often called in the psychology world. A confounding variable is something that you hadn't planned for, and it can be in a subject, it can be in the actual experiment itself, that could potentially or probably is going to throw off your results. For instance, if I was going to give a test, let's say we're going to do a computer-based reading test, and we're going to give this to all the teachers, and I show up on the day to take my reading test, and I am blind as a bat, but this morning I couldn't find my glasses. So I show up, I have to have these to read. It's not true. These are just blue blocking light glasses. Have to have these to read. And on the day of the test, I'm sitting at my computer going like this, but I still want to take the test because I want to help you. Boy, I think that's probably, I don't know, and I hit this button. Well, now my test, I'm going to take it because I'm trying to be helpful, and I don't want to tell you that I've screwed up, but my test scores are going to throw off what's going on. I had a friend in college, he could volunteer for different studies for extra credit points in class. And a friend who was a diabetic, and he showed up to do what he thought was a memory test, and he hadn't eaten breakfast, and his blood sugar was really low. But what we had to do is we had to look at a list of grocery items. Okay, simple grocery items. It was like 50 things on the list. We got 2 minutes to look at the list, memorize as many as we could, and then we had to write down as many as we could. And then we got given a different list, but while we were doing that list, we had to run on a treadmill. Okay, well, as he's running on the treadmill, his blood sugar is crashing. Your memory works way less. And so that would be a confounding variable. Someone who has a heart problem, someone who, has an allergy to something that they didn't divulge to you that may be involved in the experiment. The way the weather can affect an outdoor thing, things that you hadn't necessarily planned on that can screw up your findings. Obviously, there are confounding variables in everything in life. If you coach a sport when you get older, and let's say you coach a football team, and you coach a passing team, you like to throw the football. You want to throw the football 60 times a game, but on the day of the game, there's a 60-mile-an-hour wind and it's raining. That's a confounding variable. It's going to screw up what you wanted to do. All right, more complicated, the independent variable. I call it the IV. I try to keep things short for you guys. The independent variable, or the IV. This is the variable that you, as the scientist or experimenter, can change or control, that you're hoping has an effect on the outcome. So this is the thing that you control. All right, you have a say in how much of it somebody gets, or when they get XYZ thing, or when the test is done. And so this is honestly the big part of the experiment. This is the part of the experiment that you're testing. This is the thing that you want to see if it works, if it doesn't work, if it impacts performance. All right, what is the thing that's happening? And so in my sample hypothesis for my card, I'll show you my thinking on these, on 2 of them, and then we'll do a little pause and think. I'll take one of the easy ones and one of the medium ones, and I'll do them myself in kind of a think aloud. All right, so my hypothesis is taking 1 aspirin per day reduces a person's risk of heart attack. So obviously, that's a hypothesis. So if I'm looking at this and I'm like, what is the thing that the experimenter is controlling in the subjects, whether or not they're eating what they're getting? And so I look at this and I'm like, okay, they can't control whether or not you're going to have a heart attack, but they can control whether or not you're taking an aspirin a day. So my independent variable in taking 1 aspirin per day reduces a person's risk of heart attacks is going to be the aspirin. Okay, I'm going to do kind of the medium one. Eating red Skittles results in kindergartners displaying higher IQs. Well, I can't control kids' IQs. I can't control that they're kindergartners. And so the thing that I'm going to look at is the thing I can't control is whether or not they're eating Skittles or eating red Skittles. Okay. In this case, the independent variable is going to be either red Skittles or what color Skittles the kids are eating. There's a little bit of play there. Now I'm going to read one to you. I'm going to pause for, it's going to seem awkward because I'm recording this. I'm going to pause for a period of time, let you think about it, and then I'll give you the answer. So, drinking sugary drinks daily leads to obesity. One more time. Drinking sugary drinks daily leads to obesity. What is the independent variable? All right, I paused for a 10 count in my head. So in the example, drinking sugary drinks daily leads to obesity. The independent variable would be sugary drinks. Does the person drink sugary drinks? Okay. The last one. This is a complicated one. I want you guys to listen to this. I'm going to read it twice to you. Pick out the thing that the experimenter can control or the independent variable. People are more likely to help in an emergency situation on a Monday than any other day of the week. One more time. People are more likely to help in an emergency situation on a Monday than any other day of the week. I'm going to pause for a 10 count. Okay, so what is the thing that the experimenter has control in that one? This one's a little trickier because it's not necessarily something they can control about the person or they give the person, but it has everything to do with the when. And so in this case, the independent variable is when the emergency situation is set up. People are more likely to help in an emergency situation on a Monday than any other day of the week. So you could write day of the week that the experiment is done, day of the week, something like that. All right. So remember, your independent variable is something that you, as the experimenter, have some control over. Okay. The next thing is the dependent variable, the DV. Again, just simple abbreviation. This is the variable that's being tested and measured in an experiment. This is your result. This is the thing that you're going to measure in the end. Did their cold go away? Do they have the flu? Are their muscles getting larger? Are they smarter? Is their hair growing back? Shut up. Okay. But the thing that you can tangibly measure in the end, your result, is your dependent variable. And so I'll go through the same two I did before. Taking 1 aspirin per day reduces a person's risk of heart attack. Dependent variable is going to be the risk of heart attack. Do they have a heart attack or not? All right, number 3, eating red Skittles results in kindergartners displaying higher IQs. It's going to be their IQ. All right, their intelligence quotient. Okay, now it's your turn. All right, number 2, drinking sugary drinks daily leads to obesity. I'll pause for about a 5 count here. Okay, so what are we measuring in the end? What's the dependent variable there? Drinking sugary drinks daily leads to obesity, whether or not the person's obese. Obesity. Last but not least, people are more likely to help in an emergency situation on a Monday than any other day of the week. Okay, you're looking at, are they helping the emergency situation? Okay, now, the last thing that we're going to consider in our operational definition when we're setting things up are the groupings. We're going to have 2 groupings. We could have a couple of experimental groups if we wanted to, but in this case, we're going to keep things simple. Your experimental group or your EG are going to receive the critical part of the experiment. They're going to be given the independent variable. They're going to be the people that are participating in the difficult part of things or the experimental part of things. I'm actually going to cover the next one before we go back to the examples. The control group, the CG. They're either given nothing or they're given a placebo. Remember that placebo can be something similar. And so if I look at these and I say, okay, taking 1 aspirin per day reduces a person's risk of heart attack. My independent variable in that one was, do they take aspirin? And so my experimental group is going to be given an aspirin a day. My control group, I could give them nothing. I could give them something else. The trick there is if I give them something else, I can confound things. But let's say I give them an ibuprofen, just so they feel special. Okay? All right. My other example, where eating red Skittles results in kindergartners displaying higher IQs. Now, this is a little bit more specific. My experimental group are going to eat red Skittles. Red Skittles only. They get the best ones. My control group, they could have Starburst. They could have nothing. Or you could give them any other color of Skittle that you want to, but it can't be red. The experiment is the red Skittle. Okay? Now for you, drinking sugary drinks daily leads to obesity. What's the experimental group going to be given that the control group isn't? Or I'll give you a 5 count. What'd you get for an answer? Because if you said the experimental group is given sugary drinks, you were right. The control group obviously is going to be given non-sugar drinks. Maybe they're drinking water. Maybe they're getting sugar-free Coke Zero, Pepsi Zero. Maybe they're drinking whatever. It doesn't matter. As long as there's not sugar in it, it's okay. All right, now, last one, complicated. People are more likely to help in an emergency situation on a Monday than any other day of the week. All right, come up with your experimental group there. People are more likely to help in an emergency situation on a Monday than any other day of the week. Your experimental group are going to do this on a Monday. Your control group can have the other 6 days of the week, but they cannot be tested on Monday. So this is the point in class where if you were in my room, I would ask you for a thumbs up, a thumbs down, or a shaky hand. I hope that you're thumbs up. I hope at the very least you're a shaky hand. If you're thumbs down, please reach out to me. We're going to try to get to some group work today. If we don't, we're going to do that tomorrow. Eventually, there will be a quiz on this either tomorrow toward the end of class or Monday. So please, if you're not understanding, please reach out. Sorry if this went a little long. I wanted to make sure you guys understood. If this was all review, I hope you blew through it and were like, God, see, why are you talking so much? Finish up your assignment. If you have questions, let me know. Stay safe. Stay healthy. See you guys soon.